I couldn't see a version of your problem, so I opened up my open math. I opened up a my open math version for section 3.3. Let me see if I can find my work here. Here it is. And it's so for number 12, it said, draw the rectangle that's inscribed with its upper corners on that parabola, and then we want to find the dimensions of the rectangle with the greatest area. Um, so what I did is I went to Desmos and I graphed the parabola. And of course, I knew this was a parabola that was here. Let me get a pointer going. I knew it was a parabola that opened down because it was the needing leading coefficient was negative and it was shifted up 3. So here's that parabola. And then they said we're going to inscribe a rectangle inside that square. So the X, I didn't draw the X-axis border, but that was pretty clear, I thought. And here's a rectangle to describe it. And what we want to do, see if I change the dimensions, see how it changes. It changes, and I know where's the maximum area. I don't know yet. So what we're going to do is we're going to create an equation for the area of this rectangle, and then we'll use that to find the maximum area. We'll do it graphically because we don't know how to do derivatives yet. And if somebody's pointing you towards a derivative, they shouldn't be because it's a pre-calculus class. All right. So I'm sorry if one of the videos did that or somebody on tutoring.com did that. So here's what I'm going to do. So the tricky part is you see how this is the X value here. Let's make it be 1. Let's make it be a nice number. If I could do it, it'd be good. There we go. So when it's 1, this is too wide, and this is also too wide or too high. Okay, so the reason is that it's going to be 1. It'll be, if we think about it, it's plugged in 1 squared is 1, and 3 minus 1 is 2. So this rectangle is two this way, too wide and too high. So it's a square. So that area would be 4. If we changed it to, I don't know, if we change it to 1/2, let's see if I can make it be 1/2. There we go. So that rectangle has an area of 1 wide by 2.75 high. So that'd be an area of only 2.75. If we went down to, so it went the other way. So I don't know if we can, how easily that'll be to do that. So if that's, whoops, it was 1.5, that might work. Maybe getting the idea. So that's 3 wide by 3/4 high. So I think that, let's see, what's 3 times 3/4? Isn't that 9/4? So that 9/4, so that's what, 2 1/4. So that area is 2 1/4 square inches. So where's the maximum area? Right now it looks like with the square, and I suspect it's going to be the square, but we'll see. We'll see where it's going to go. So how do you create an equation for this so you can do some work with it? Well, I see this is here. Let me get a pen going. So this is X, this is X, same thing. So this rectangle is 2X wide. So if this is X and this Y value is determined by the equation 3 minus X squared. So the height of this rectangle, regardless of where it is going to be 3 minus X squared. So the area of this rectangle that's inside it is going to be the width, which is 2X, times 3 minus X squared. So then A equals 6X minus 2X cubed. And that's a polynomial. That's not an easy polynomial to find where's the maximum and minimum. It isn't like it's a parabola where we can do that negative B over 2A trick. So what we're going to do is we're just going to graph that at this point in this course. We're just going to say, let's graph that area function and find the maximum. So you know what? Here, give me a minute here. I'm gonna actually save this because I like the way this came out. And I'm gonna call this section 3 number 12. That's why I get it saved in this account. And now I'm just gonna do a new, I'm gonna do a new graph, new blank graph. And I know the function that I want to maximize here is going to be 6x minus 2x to the third power. Okay. And now we got to worry about domain. Here, let me clear my writing now. Now they get that in there. So I know that I can't be that parabola couldn't be any wider than the square root of 3 in either direction, right? On the x-axis. So the square root of 3 is probably going to be right there. I don't know. Yeah, that's the decimal equivalent of square root of 3. So the maximum area, remember, this is the area equation. The y values on here is the area. And sure enough, look at that turning point. And that's where it's the biggest y value in that domain from 0 to the square root of 3. So when x equals 1, the area is 4. So my math is looking for the dimensions. So we know from that work we saw just a minute ago when we were looking at the sketch that here I'll make a little sketch. Well, I think I'll make a little sketch of it. Let's see. If we make a little sketch of that parabola, it's going to be very sloppy. And here's the rectangle. And we're seeing from this graph that when it's 1, the area is 4, and that looks like the biggest area. So that's 1, that's 1. And this is going to be 3 minus 1 squared, right? Remember, it's 3 minus x squared. So the dimensions will be 2 by 2. So it was the square that maximized it. Okay, no need for calculus, no need for derivatives. You can just do it this graphically. I mean, to do it fully analytically, we would probably need to do a derivative, but that's not here yet. You're not there yet. Okay, so hopefully that answers that question. Write the equation, write the formula, and graph it. Yeah, when you need to do something analytically, I will say do it analytically, and that's good enough. Otherwise, use the tech.